Welcome to Deep Dive Learning by HaleForm, Episode 9. Today we're taking a deep dive into a really critical area for established industrial facilities. We're talking about migrating their legacy plant design data to modern platforms.
Yeah, this is a huge topic. It's a challenge many places in energy, process, marine sectors.
Yeah,
They're all grappling with it, trying to bring that valuable historical data forward.
absolutely. So our mission today is to sort of unpack why this move is so essential. What does it actually involve? And why is it, well, let's be honest, often a significant undertaking, but ultimately strategic?
Right. It's complex, but definitely a strategic imperative for many.
Okay, let's get right to it then. We're talking about facilities maybe running on older systems like PDS, maybe PDMS.
Exactly. They were the workhorses, weren't they? For decades, really instrumental in designing complex plants. 3D models back then, that was revolutionary stuff.
For sure. But technology moved on.
It does. And those older systems, powerful as they were, they now present certain limitations, especially in today's digital world.
Which brings us to the modern stuff.
Yeah.
You hear about Smart 3D, S3D, E3D. What's the core advantage they bring?
Well, the fascinating thing is the fundamental shift. It's how the data's treated.
Wow.
Older systems, mostly graphics focused. You see the picture.
Right.
Modern platforms, they're data-centric. Every single component, a valve, a pipe, whatever, it's an intelligent object.
Intelligent how?
It has a wealth of embedded information, tag numbers, specs, materials. So we're moving from static 3D drawings to live, actionable data. You can do so much more with it.
Okay, so it's not just seeing the plant, it's understanding it much more deeply.
Precisely. And a key part of that is rule-based design. S3D, E3D. They let you build in and enforce design rules, specifications right in the software, which means more consistency, better accuracy.
And compliance, sticking to standards.
Exactly. Crucially, better adherence to standards and regulations. It's like building quality control in from the start.
Wow, yeah. That sounds like a huge step for minimizing errors and, the costly rework later.
It absolutely is. And connect that to the bigger picture. These modern platforms integrate so much better. Interoperability is key.
With other engineering tools.
Yeah, things like PNIDs, electrical schematics, structural analysis, but also wider enterprise systems.
Like ERP, asset management.
Exactly. ERP for resource planning, asset management software. It creates this much more cohesive digital environment.
And that term you hear everywhere now, digital twin. How does this fit in? Seems like a lot of buzz around that.
It's gaining huge traction, and rightly so. This raises a critical point. That rich, structured data inside an S3D or E3D model, that is the foundation for a useful digital twin.
You can't really build one without it.
Not an intelligent one, no. You
Yeah.
need that underlying data intelligence. That's what powers predictive maintenance, operational tweaks, understanding the asset over its whole life.
Makes perfect sense, like trying to run advanced analytics on a basic spreadsheet versus a proper database.
Good analogy, yeah.
So, okay, beyond the data and the rules, what else do these modern systems bring to the table?
Well, there's a range of enhancements. Better visualization, for one, makes complex designs easier for teams to grasp. Performance is generally better, especially with those massive plan models.
Which can be huge, yeah.
Huge. And better collaboration tools, too. Teams spread out geographically. They can work together more effectively. Plus, support for integrating newer tech, like laser scans, getting that super accurate as built data into the model.
Okay. Capturing the reality on the ground.
Precisely. And then there's the sort of future-proofing aspect, sticking with outdated software. Eventually you hit walls, vendor support dries up, compatibility issues with new operating systems. You miss out on innovation.
Right, so it's about using today's best tools and being ready for tomorrow. Okay, let's shift gears a bit. The data itself. When a company bites the bullet and decides to migrate, what exactly gets moved? It's not just the pretty 3D picture, is it?
Oh, definitely not. You're
Yeah.
spot on. The 3D geometry, equipment, pipes, structures, that's fundamental, sure. But it's just one piece.
What else?
All those associated object attributes and properties, tons of them. We're talking tag numbers, the unique IDs, detailed descriptions, material specs, line numbers for pipes, insulation details, even operating parameters like pressure, temperature.
Wow, all the critical details engineers and operators actually use day to day.
Exactly that. And then there's the connectivity, the relationships between components.
How things are linked up.
Yeah, how things connect, how they interact. The new system needs to understand all that, just like the old one did. And, importantly, the catalogs and specifications. These define all the standard parts and materials.
That sounds complicated to move.
It often requires significant attention, yeah. Reconciliation can be tricky. That's actually an area where specialized expertise really helps. Companies like HaleForm Technology Solutions, for instance, they have teams focused specifically on catalog customization.
Because it's not a simple copy-paste.
Rarely. The structure in the old systems versus the new ones, often quite different. It needs careful mapping, sometimes even rebuilding the catalog in the new environment.
To ensure it's consistent and accurate going forward.
Exactly. And sometimes you also need to consider the associated 2D drawings generated from those old models, how they fit in.
Okay, so it's a really comprehensive effort. The visual model, plus all the underlying data, relationships, definitions. Can you walk us through the main stages? What does this migration process actually look like?
Sure. It's definitely a multi-stage journey, and it always kicks off with thorough assessment and planning, always.
Got to know what you're getting into.
You really do. What are the objectives? Is it for a specific revamp project or a bigger digital twin initiative? You need clarity. You assess the quality of the source data, the PDS or PDMS models. How good is it, really?
Any hidden problems?
Potentially. You need to understand the target environment, X3D or E3D, and configure it properly, define the scope clearly, what exactly is moving, which parts of the plant, and select the right tools and methods. This initial planning is just critical for success.
Makes sense. Are there services that help with just that planning part?
Oh, yes. Companies like HaleForm Technology Solutions, they offer services to assist right from that initial assessment and planning stage. They can help lay that solid foundation. You can reach them at business.development@haleform.com.
Good to know. Okay, groundwork laid. What's next?
Next up is data extraction, getting the relevant model, data, geometry, attributes, everything out of the legacy PDS or PDMS database, usually into some kind of intermediate format for processing.
Get the data out. Simple enough in concept.
Then comes arguably one of the most critical and often challenging phases, data cleansing and mapping.
Cleaning up.
Yep. Finding and fixing inconsistencies, errors, missing info in that extracted data. And at the same time, mapping attributes, like this material code in PDS means this specific material spec in S3D. That mapping has to be spot on.
Requires knowing both systems inside out, I imagine.
Deep understanding, yes. Detail is paramount there.
Okay, cleaned and mapped. What follows?
Then that catalog and specification reconciliation we mentioned earlier. Comparing the legacy catalogs with what's available or needed in the target system often requires a big effort to ensure equivalent components, materials, design rules exist or are created properly in S3D or E3D.
And again, that's where specialists might come in.
Absolutely. Like the catalog customization teams at HaleForm Technology Solutions, their expertise there can be invaluable for a smooth, accurate transition. Saves a lot of headaches.
Right. So cleaned, mapped, reconciled. Now we load it.
Now we move to data loading and transformation. This is where the prepared, mapped data actually gets imported into the target S3D or E3D environment. Specialized tools do this, transforming that intermediate data into native objects in the new platform.
Okay, the data is finally in the new system. Are we done?
Almost, but not quite. The crucial stage of validation and quality control comes next.
Checking everything.
Rigorously. Comparing the migrated model against the original source. Is the geometry right? Did all the data transfer correctly? Verifying properties, relationships, connectivity. Running clash detection to find any new interferences. Checking compliance against the new system's rules.
Also health check, basically.
Exactly. Making sure everything is as it should be.
And after the checks.
Then the final phase, post-migration. This involves training users on the new platform and the migrated data. Might involve integration work, connecting the model to other systems, and eventually maybe archiving or decommissioning the old PDS or PDMS system.
It really does sound like a significant undertaking. Lots of places where things could get tricky. What are the common challenges people run into?
Yeah, there are several common hurdles. A big one is just poor quality legacy data. After years, models can get inconsistent, data goes missing, standards weren't always followed.
Stuff gets messy over time.
It does. Another major challenge. The fundamental structural differences between old systems and modern data-centric ones like S3D, E3D makes that mapping complex. Those catalog and spec mismatches we talked about, very frequent difficulty.
Right.
There's also the potential loss of design intelligence. Maybe some relationships or parametric rules from the old system don't translate automatically.
Things get lost in translation.
Sometimes. And customizations. Many legacy systems had custom macros, reports. Those need assessing, maybe rebuilding. HaleForm Technology Solutions actually has programmers skilled in things like hangars and support customization, 3D symbol customization, rule checker service customization. They address those specific needs.
So handling the unique bits of an old setup.
Exactly. Then there's just the sheer scale. Huge plant models are complex to manage during migration, and maybe the biggest underlying challenge. You need deep expertise in both the legacy and the modern systems.
You need people who understand both worlds.
Precisely. And that's where companies like HaleForm Technology Solutions, again, bring value. They employ multidiscipline smart 3D modelers, smart 3D administrators, people with that specific cross-system knowledge. You can find out more via business.development at haleform.com.
It really highlights the need for that specialized know-how.
Yeah.
Trying to do it without could be tough.
Well, absolutely. It can lead to delays, cost overruns, and maybe an end result that isn't quite what you hoped for.
So, okay, we've talked about the complexity, the challenges, but despite all that, why is this migration ultimately seen as a strategic investment? Why go through it?
Because the benefits, despite the complexities, are substantial, really far-reaching. Modern platforms mean improved data integrity, more reliable info for crucial decisions all through the plant's life.
Better decisions based on better data.
Exactly. Enhanced design efficiency, too, through rule checking, automated workflows, better collaboration, which leads to a reduced rework, lower project costs ultimately.
Saves time and money.
Right. And crucially, as we touched on, migrating to a data-centric platform like S3D or E3D, it builds that strong, future-proof foundation for digitalization, enables advanced analytics, effective asset lifecycle management, all that good stuff. Helping companies overcome the migration hurdles and realize these strategic benefits is exactly what specialists like HaleForm Technology Solutions focus on.
Okay, let's try and unpack what this all means for you, the learner, listening in. This migration. It's clearly not just swapping out some old software for new. It feels like a fundamental strategic shift, moving towards a more data-driven, efficient future for these big industrial facilities.
Yeah, and here's where it gets really interesting, I think. By transforming the very, DNA of their engineering data, companies unlock totally new possibilities. Advanced analysis, seamless collaboration, building those living digital twins we talked about.
Getting insights you just couldn't get before.
Exactly. Into operations, maintenance, future improvements. It's a whole new level of understanding.
So whether you're directly involved in projects like this, or maybe you're just curious about how major industries are evolving technologically, understanding this transition gives you really valuable context. Being able to leverage these intelligent 3D models, it's becoming more and more critical out there.
Absolutely. And maybe this raises a question for you to think about. How could those core principles, data-centricity, rule-based design, which are so key here, how might they apply elsewhere? In other parts of your professional life, maybe even personal life?
To improve efficiency or accuracy?
Yeah. It's not just about plant software, is it? It reflects a broader shift in how we can manage and use information more effectively, a different way of thinking.
That's a great thought to leave people with, a really interesting angle. And if you are interested in digging deeper into this specific topic, or maybe understanding how a company like HaleForm Technology Solutions, again, that's business.development at haleform.com, can actually help with these complex migrations. We'd suggest looking into case studies, maybe white papers. They often show the real-world benefits of moving to these modern plant design platforms.
Definitely worth exploring if this area touches your work.